Hey guys, welcome back. In this video, I will mainly talk about the pre-coding based beamforming. How is it actually going to influence the RF antenna beam? Okay, for that I had a lot of background in the previous videos to explain this. The first thing is I was talking about analog beamforming, where we want to transmit. We want to form the beam, analog beam, in a particular direction, something like this. Then I was mentioning that we need analog phase shifters across antennas, right? This is one concept which I was mentioning. Then in the previous video, especially with respect to the hybrid beamforming, I was mentioning that in spite of using these phase shifters, we can perform the similar phase shift operation in the digital domain, something like this, so that we will have the equivalent effect of phase shift across the chain, and hence the RF beam can be formed in the required direction, right? So now we will see with these two concepts, okay, how the pre-coding based beamforming is influencing the RF beam. For this, first what I will do, I will take the pre-coding block. Let's say the output of pre-coding block is x1 of n, x1 of n, here for now, for an example. So afterwards we have many signal processing block. I have not written over here. Then there is RF chain as well. This includes, okay. Then the signal coming out is S1 of t, S1 of t. Each of these chain have expanded here below, okay. Let's say this x1 of t, first it goes through remap, then there is a waveform signal generation, cp addition, and things like that, and then finally we have digital to analog converter, and then RF chain, and finally we arrive at s1 of t, right? So here we can give analog phase shifter phi, or we can give the equivalent phase shift in the digital domain, which is x1 of n into the power of j phi. Both are having the similar effect on the RF beam. That's what we discussed. So here all the signal processing blocks also have mentioned. Now we will take this entire thing as a black box, and let us try to see what happens during the decoding. So first is that I will take uh, a more specific example, that is the precoding. Let's say this is a precoding block. The matrix W which I am going to take is 1j and 1 minus j. So let's say the input 2 is a 2 layer, okay. So x1 of n and x2 of n, these are the two layers. Then for the sake of simplicity, in most of the cases I have taken a 2 cross 2 as the example. So number of antenna ports, output of the precoding is also 2, okay. Now I will write this black box. This entire thing has some signal processing blocks and including the RF chain. Okay. Then I'm going to get here S1 of t and S2 of t. Okay. Then um, optional whether we want the analog phase shifters or not. This is optional. Okay. So then it goes to antennas, physical antennas. Now the thing is, if we are going to perform something like this, okay, what is the signal at this point? The signal at this point can be written as I was writing in the previous video. We can write it as x1 of n into the vector 1j plus x2 of n into vector 1 minus j. And so this is where I was mentioning that in case of precoding, the beams are formed along these directions. These are the vectors which defines the directions in the space whose dimension is of number of antenna ports. This is what I was mentioning, right? So now, after understanding this one, what we can say is this vector can be, how can we write this vector in a different way? So one can be represented as a 0 degree we are giving. J means, what can we say? J is 90-degree phase shift. So to this x of 1, we are on one antenna we are giving 0 degree, on the other antenna we are giving a 90-degree phase shift, and similarly here 0 degree and minus 90-degree phase shift. So basically, as I was mentioning, that whatever the phase we gonna perform in the digital domain, we will have the similar effect in the analog domain, right? So at this point in time, how does my signal look? So it will be s1 of t, okay, plus 0 degree phase shift. I will write it like this. So then S1 of t plus 90 degree phase shift. Okay, so then here we have two beams, right? Because we x1 of n and x2 of n, we have two beams. So similarly, we have one more quantity which is s2 of t 0 degree and s2 of t plus 90 degree. So basically, what kind of beam would be formed from here? So already we had seen the previous video, for a phase shift of 90 degree, we will get the direction of beam is 30 degree, right? So for S1 of t would form in the direction of 30 degree. So the beam would be forming in the direction of 30 degree. Okay. And what about minus 90 degree? That would form the beam in the direction of minus 30 degree. Okay. So I hope this is clear. So this is 0 degree, this is 30 degree. So so it is clear that whatever the precoding that we gonna give, that that we can map it to some phases that is acting upon the signal x1 of n and x2 of n, and once we know that, we can clearly say how this is going to influence the analog beam. I hope you got the clarity. By see here, we have not used any analog phase shifters. Here this is not used. Okay, so I had given just precoding matrix. From precoding matrix in the digital domain, I am seeing that to the vector x1 of n, it is equivalent to giving 0 and 90 degree, and hence the signal or the beam from the antenna is formed along a 30 degree direction. Okay, so I hope you got this clarity. um, Even if we try to, we can apply some more phase shifters in the analog domain by considering some phase shift value. If we do that, then it would become both precoding based beamforming is also happening. As I was telling, precoding based beamforming is also digital, is also nothing but digital beamforming. Plus we are also going to perform some kind of analog beamforming here by giving the phase shift value in the analog domain. Since both are done, then we can say even hybrid beamforming is also happening. Okay, so this is the one aspect which I wanted to explain, mainly considering the previous videos. I hope this is clear. In the upcoming video, we will see how, even though the precoding matrix, okay, we had formed the beam in this way, 30 degree and minus 30 degree, which is coming out of the antenna. Even though we formed the beam, how this is going to change the beam direction with the influence of the channel movement. Okay, thank you very much. Have a great day. Bye bye.